Bismillahirrahmanirrahim. So for this week, we will continue with the chapter 4, the Structural Geology, okay, or the rock deformations. Okay. So at the end of this chapter, the students should understand the followings. There are few terms that we need to understand. A little bit on the introductions of the geology structure, and then the strike and deep. What is strike and deep? The full structures, okay, and then faults. And kita nak tengok full, faults, joint, and conformity structure, and also the geological mapping and terminology. Alright. Okay, a little bit on the introductions to geological structure. Okay, the study of rock deformation. In terms of deformations, the changes, the rock changes. Okay, alright. Okay, so actually from the structural geology, what we can identify from the structural geology is actually the historical. Okay, the history of the deformations. And then it's about to study the events in the previous geological activity. Okay, and then we also want to understand the geometries, the rock geometries, and also what makes the rock deform from previous to the present time. Okay. So over the past of thousands of years, okay, as we go through the tectonism process, the plate tectonic movements, okay, so it's actually the earth has been mobile, due to the tectonism. There are lots of changes, okay. So the rocks we see now near or at the surface, no matter what their origin, has been squashed, stretched or fractured. So they have been deformed actually. As I mentioned earlier about the metamorphic rock. Actually the metamorphic rock formations only underneath the ground surface. Okay. By right, kalau ikut by definition, kita tak boleh nak nampak that metamorphic rock, but then due to the plate movement, due to the erosions at the surface, so nowadays we can see that the metamorphic rock at the surface of the ground. Okay, so the deformations arise due to the large part of the lithospheric plates, okay, the movement, and then the movement will generate stresses. Okay, so the movement, okay, yang akan generate stresses. Okay, so whether it compress, collide each other, ataupun it tension, break apart or stretch. Okay, so all the deformations, the changes of shape, the changes of size, sometimes we call it as a strain. Okay, what make the strain is stress. Okay, apa yang menyebabkan changes, apa yang menyebabkan perubahan is the stress. Okay, alright. So what is the deformation? Refers to any change in volume or shape caused by stress. Okay, so whether it by the uniformity of the stress or differential stress, okay, it will cause changes to the rock, whether it's volume or whether it's shape. Okay, so you must remember these two terms, stress and strain. I think in a solid structure juga you ada jumpa this term, stress and strain. Later next semester in soil mechanics also you will be introduced with the stress and strain. The word used, the term used to describe about the deformations. Okay, each of material akan ada deformations. For example, steel, keluli akan juga deforms. soil itself, tanah soil juga akan deform. So same goes to the rock, juga akan deform, okay, due to the stress applied. So what is stress? So stress is the force applied to a body over unit area. Okay, force over area dia sama juga dengan stress. So the unit is normally kilonewton per meter square. And then what is the deformation? Change in size, shape or volume. When the material body and the rock experience stress. Okay, so strain is proportional to the stress. Large stress will result to the large strain. Okay. A little bit introductions on the stress. There are two types of stress. You have the uniform or confining stress. Okay, ini term yang quite common dalam all the subjects yang related any with deformations. Okay, so you have the terms of the uniform ataupun confining stress. Sometimes you're going to term confining pressure. Okay, bila kata uniform or confining, meaning that force on a body that is equal in all direction, uniform stress. For example, stress equal from all directions. Let's say from this side, the body of rock receives around 10 kilonewton per meter square. Same goes from the top, 10 kilonewton per meter square, 10 kilonewton per meter square. Is actually isotropic. Isotropic meaning that all around the material it will receive the same amount of stress. Okay, alright, so basically due to this stress, this uniform confining stress, what will deform is actually the change in size there. Okay, size there, from the larger size to the smaller size. Okay, it's like compressions. Okay, in terms of size. Okay, in terms of size, rarely it change in shape, because it receive the uniform stress. Okay, alright, and then what is another stress? Another stress is the differential stress. Okay, so since the terms is the differential stress, meaning that the amount of stress is not equal in all directions. Okay, and it caused by tectonic forces during the tectonism's movement, and usually it will change in shape but not in size. Okay, since it receives different amount of stress. Okay, so it will change in terms of shape. In differential stress, they have another 3 type of stress. For example, we have the tension, stretching stress. Okay, so bila kita tension tarik lagi left and right, so the shape will change. Okay, and then compression. Okay, compression with differential stress. Okay, a squeezing stress. So compression, a squeezing stress, that rock are relatively strong under compressions but not in the tensions. Rock biasanya dia tak kuat bila lawan dengan tension force. Okay, and the last one is the shear stress. Stress operate in opposite direction across the body. Okay, if we want to relate it with the plate tectonic movement, okay, for the differential stress, okay, what kind of plate tectonic movement? For example, tension. So the tension movement is actually can be related with the divergent plate movement. Bila two plates move apart of each, and then so it can be related with the divergent plate movement. Chapter 1, I hope you still remember. And then when we are dealing with the compressions, we can relate it with the convergent plate movement. sorry with the writing because I write on the screen. And the shear stress, it can be related with the transform fault tu yang dia sliding each other tu, right? So basically this is what we have. What will happen to the rock when it receive the compressive stress, the folding, can also be faulting, tension, the stretching and thinning in the middle of the plate also can cause to the faulting. What is fold, what is fault, later I will introduce to you. The shearing, what will happen due to the shearing, and also can cause to the faulting. Alright, so when a rock is subjected to increasing stress, it's actually there are 3 stages of deformations ataupun 3 stages of strain. The first one is the elastic deformations, and then the plastic ataupun ductiles. The definition is the same, whether it's ductile or plastic. And the last one is the fractured. This is the stages. So the first one, it will elastic. Elastic meaning that strain is reversible. Maknanya it can back to the original shape once we apply the load and then we remove the load. That material, okay, so that rock can return to the original shape. But when it achieve to the plastic deformations, the strain is irreversible. Maknanya dia tak boleh nak reverse balik to the original shape. Dia akan permanently strain, berubah di situ once it's at the plastic point. Okay, alright. And the last one, after the certain stress that the rock ultimately can receive, it will fracture. Fracture mean the failure point lah. Okay, failure point, it will permanently strain when stress exceed the strength, and the rock will break, pecah or fractured. Okay, the last part. So this is the commonly stress strain curve. This one is elastic actually. Gambar ni kembang tak nampak. So elastic limit, this is an elastic limit. Maknanya any material that dia naik from this up to this point, if you remove the load, it can back to the original shape. That is elastic. But then if you apply the load more than this, apply stress more than this point, you apply more than this point, it will starting ductility. Dia akan mula masuk ductile deformation, ductile ataupun plastic deformation. So bila dah masuk this area, dia dah masuk this area, this is the permanent strain. Maknanya dia tak akan boleh back to the original shape. And then once you increase another load, bila you increase lagi another load at certain point, and the rock finally will break and fracture. So kat sini dah fail lah maksudnya, right? Okay, this is the common stress strain curve. Okay, so actually we can divide materials into 2 classes. We call it as a brittle material, and we have another one is ductile material. So brittle material actually is only have a small or large region of elastic behavior. Okay, sorry, it's actually have a large regions of elastic behavior. So elastic behavior punya part is quite large compare with the ductile punya deformations. The small region of ductility, then dia akan fractured. Compare with the ductile material, okay, dia ada small region of elasticity, but then they have a large regions of it has a small regions of elastic but have large region of ductility. Okay, after receiving ductile deformations in a quite long time, then baru dia akan start fail kat sini. Okay, this is for the ductile material. Okay, there are few factors yang affect this kind of behavior So the first one is the temperature. Okay, so at high temperature, maknanya getting hot, also all the molecules they boleh stretch and move. Okay, so they behave in more ductile manner. Okay, at low temperature materials are brittle. Okay, confining pressure, at high confining pressure, maknanya pressure yang tekanan yang lebih tinggi, are less likely to fracture because the pressure surround tends to hinder the formation of fracture. At low confining stress, material will be brittle and tend to fracture. And the at high strain rate, material tend to fracture. The deformation rate yang tinggi, possibility untuk fracture tu lebih tinggi. Alright. And also compositions. Okay, some minerals ada yang brittle, say like quartz, olivine and fracture. Brittle ni maknanya you apply small amount of pressure, dia dah pecah. Okay, compare dengan yang ductile. Ductile dia akan ambil masa yang lama untuk dia that rocks or that material to fracture. Brittle ni sangat rapuh. You apply just only some amount of pressure or stress, then dia akan terus fracture. Compare with the ductility, maknanya material yang ductile ataupun yang plastik, kena apply stress yang lebih tinggi sebab dia punya ductility deformation tu lebih panjang, then baru dia akan fracture. Okay, so itu the difference between brittle rocks ataupun brittle materials with the ductile material. Alright, okay.